Assalamu alaikum. Today we are going to present the final project for the subject System Analysis and Design. The final project will be KAU UDUS Course Registration System Analysis and Redesign. This is our group, me Abdullah Shehri and my good friend Riyad Muhammad Al-Aqsam. This slide shows the data flow diagram for the current system. This diagram illustrates how students interact with the system to register for courses and manage their academic schedules. This diagram identifies four main components. First, you got the external entities colored in blue. You got the student who initiates the learning process, and you got the admin who manages and maintains the system. After that, you got the processes, which colored in green except for the add and drop course process. We've highlighted in purple because it's the most significant process and the main process we are going to talk about in this presentation. However, after that, you got the data stores colored in yellow, which stores key information, important information about the student, about his schedule, about his records, etc. And lastly, you got the arrows, which are the data flows, where the data go, where the data went, where does it start, where does it end, and so on. So to sum it all up, the student put his login credentials, his university ID and password. The user registration / authentication process go to student records, verify the student, and gives back authentication status, either give access or deny access. After that, the student go to see the available courses. Hence, the display course catalog process. This process checks the course catalog, retrieve the courses, and show it to the student. After that, the student now can add or drop courses, and that doesn't happen before validating prerequisite first, which check the eligibility. Is the student eligible to add this course? If yes, and validated, it is added and generated in his weekly schedule, and that information is stored in the schedule data store. All this information, all this record is updated and stored in the registration data through this process right here. And let's not forget the admin, who update the course catalog frequently and sometimes manually override the registration data. Let's move on. This is the same thing I've said, but more thorough. Let's move on. After we've seen the current system and analyzed it, now we can identify pain points for the current system. First of all, you got poor user interface. The options I want to reach as a student are hidden behind menus. I need to search all over the website to get to them, to find them. Secondly, no real-time feedback. The seat availability for each class is ever changing, but I don't know that. But I don't when the class is empty and when the class is full. That resulted in many lost opportunities to register in a course. After that, manual prerequisite checks. The prerequisite checks, sometimes it works, sometimes it not. After that, lack of integration with advisors. I've always needed to go to the advisor's office, not in the system. After that, system crashes during peak times. That happens every single time, every single semester. And lastly, inefficient scheduling tool. This relates to the poor user interface. The scheduling tool, I need to search all over the website to find it. That time could be spent in actually registering for courses. Moving on. This slide shows the data flow diagram for the new system, our proposed system. In this new system, apart from the usual processes like user authentication, you have some upgrades like display smart course catalog. It's an upgraded user interface for UDUS Plus. Also, you got AI-based course recommendations, which shows the student exactly what courses he should enroll in. And you got automated prerequisite checks, which make the process much easier. And real-time seat availability checks, which solve a ton of problem for us students. And on top of all that, the advisor is finally in the picture. When the student adds or drop courses, there's an advisor approval workflow. He review the request, then he accept or reject it. So the student has much better help in making his schedules and enrolling in classes. This redesign balances automation with human oversight, streamlining registration while maintaining academic controls. See, same thing here. The proposed level 1 DFD enhances the original system with AI-driven efficiency and advisor oversight. You have smart workflows, AI recommendation, analyzing the student history, and real-time seat checks prevent registration conflicts. Advisor's role, a new approval workflow ensures compliance for restricted courses. Logged in, a dedicated advisor approvals data store. Automation, instant prerequisite validation, and dynamic catalog filtering reduce manual errors, while admins retain override capabilities. The admin has the same capabilities as before. This redesign balances automation with human oversight, streamlining registration while maintaining academic controls. This is the use case for the new system. It illustrates how different users interact with the system. To go about it quickly, you got the student. These are the external entities. You got the student who select the semester, browse course catalog with the help of AI-based course recommendation, and register for course. Both of these include real-time seat availability. After that, he submit course change request and view his weekly schedules, or drop course if he wants to. You got the admin, like usual, manage course catalog, update semester settings, monitor system performance, and resolve registration issues. And as for the advisor, he reviews student course plan. Then he approves or denies course registration, and after that he generates an academic report. So it's a more thorough, more helpful, more efficient system. And this slide says exactly what I just said, and now I'd like to take it to my good friend Riyad Aqsam.
Assalamu alaikum, Riyad Al-Aqsam. Tangible benefits of the redesigned system. These are measurable, quantifiable improvements resulting from the new system. First one, we have faster registration process, which give real-time seat availability that goes up to 40%. Second, reduce system crashes during peak times, which improve back-end infrastructure and cloud-based load balancing ensure system stability even during high traffic periods. Third, higher accuracy and prerequisite validation. Automated validation reduces course drop rates due to unmet prerequisites by up to 60%. Fourth, improved advisor approval. Built-in advisor workflow shortens approval time from days to hours. Fifth one, better resource allocation. Real-time enrollment data helps administrators plan course offerings and instructor assignments more effectively. Tangible benefits of the redesigned system. These are non-measurable but impactful gains that improve user experience and satisfaction. First one, we have enhanced student satisfaction. A modern, intuitive interface improves overall user experience and reduces frustration. Second, increased confidence in course selection. Students feel more confident knowing their selected courses meet all requirements and avoid schedule conflicts. Third, improved academic advising experience. Advisors can access student plans directly within the system, allowing for more effective guidance. Fourth, greater transparency and trust. Clear visibility into course details, instructor timing, availability that builds trust between students and the university. Last one, streamlined communication between stakeholders. Integrated notification and messaging reduce miscommunication between students, advisor, and admins. We come to the end. Thank you very much, Dr. Yasser Al-Hisawi, for listening, and special thank from me and my friend Abdullah Shihri for everything you've done to us this semester.